Hello everybody. Today we'll be walking through how to use the PyCharm Profiler to speed up your code. If you've ever been in a situation where you're trying to optimize your code because you're in a large repository or you're using a script that takes quite a lot of time, one of the first things you might start doing is putting a bunch of print statements everywhere, right? So you'll put a print statement before certain executions in the code and then try to gauge how much time each thing is taking. However, that's I would say, the naive way to do it. It's very clunky. You have to go through your whole code, and for larger code bases, it becomes impossible to do this. However, optimizing your code is still a step that needs to be taken quite frequently. So if you need to do this, something like a profiler, and in this particular one I'll be using PyCharm Profiler, is a perfect way to look at your code. So in a profiler, it will give you the call stats. It will tell you all the calls that were made, how many of them were made, how much time it took, and also very helpfully, it'll give you a call graph. So it will show you the different scripts that were ran, how long each method in those scripts took to run, and how long the sub-methods and built-in methods took to run. And this will give you a great starting point for where to look to optimize your code. So let's take a look at this by looking at the example I have set up right here. First, let's just zoom in a little bit. Oops, there you go. And now for our first function, sleep for. It's a very simple function. We pass in a certain amount of seconds and it sleeps for that many seconds. The second function is smaller, again a very simple function. It just compares between two numbers and returns whether number 1 is smaller than number 2. So looking at this third function here, get max n2, this gets the maximum of a list in n squared time complexity. So let's just quickly run through the code and see what's happening. We are first declaring some maximum to be negative infinity, right? Then we're iterating from starting to the end of the list, so I to n. And for each number in the list, we are checking if isMax equals true. So the way we do that is we iterate through the list again, and we simply check if this number we're currently looking at, nums at I, is greater than all the other numbers in the list. If it is, isMax equals true is going to remain true, so our maximum is going to become nums at I. If at any point we see another number that is smaller than nums at I, then it is going to become false, and we are not going to update max. And finally, we're going to return maxi, which is going to be the maximum value in this list. As you guys can see, this is very unoptimized. And we can optimize this n squared version as well, but we're going to leave it as is, just so we can see the length of time it takes for this to execute versus some of the other functions. So now here is a slightly better function, get max of n. That gets the maximum in a list in linear time. So we're doing the same thing here and earlier, except instead of iterating through every number in the list, we're just checking the current number we are versus the current maximum. So the current maximum starts off as negative infinity, so any integer will be greater than that, or I shouldn't say integer, any number should be greater than that as long as it's not infinity. And then we get the max between those two numbers using the built-in method max. So finally here, we are now just declaring an array, right? So this is going to be x for x in range 1000. So this is going to be an array from 1, or I should say from 0 to 999, so it's going to have 1000 elements. So the first thing we're doing is we're sleeping for a second. Then we are getting the maximum of the array in n squared time using get max n2. Then we're sleeping for 2 seconds. And then we're getting the maximum in linear time using get max of n. So if we want to see where the bottleneck in this script is, we could put a print function after every single one of these calls to get a general idea of how long the time it took. But we wouldn't be able to see what calls were being made and how many of them were being made. And also, like we had mentioned earlier, for larger files and for larger repositories, this becomes impossible and a very messy way to do things. So in comes the profiler. The profiler is pretty fantastic. So we're going to come over here. So you're going to see this time clock right here, profile example. We're going to click run on it. It's going to start the profiler, and it's going to run the code. And there you go, the code has been ran. So now if we're looking here at the statistics, we can see the name. So this is the name of all the different functions and the scripts that were ran, how many times they were run, and the time it took them to run. So we can see example.py, the script got ran once. We can see getMax got ran once. We can see getMax n squared ran once. But over here we can see that get max took 0 milliseconds, whereas get max n squared took 409 milliseconds. And then we can also see sleep 4 took 3000 milliseconds, or 3 seconds, which is about right if we consider we passed 1 and then 2 afterwards. And then let's look at the call graph here. The call graph is a very helpful feature. So here we can see that the total time it took for this script to run was 3.5 seconds roughly, or 3,418 milliseconds. So if we look here, we can see that there are different colors, and all the colors represent basically what is responsible for adding the most runtime to our script. And we can see that right now the most one is sleep 4. Sleep 4 took 3,000 milliseconds, and it's using the built-in time.sleep, which is what took the 3,000 milliseconds total, or the 3 seconds. So let's say we want to optimize this. So there you go. We're now no longer calling the sleep for a function. So now let's run it again. And again, now we see the same statistics, right? But this time we're not running the sleep function. We're seeing isSmaller got called 1,000,000 times. We're seeing the built-in max method called 1,000 times. And now when we look at the call graph, it's slightly different. And now we're seeing example.py took 420 milliseconds compared to the previous test, which was 3.5 seconds. And now we can see that now we no longer have the sleep method there. The next method that's contributing the most to the runtime currently is get max n squared. So over here, we're seeing that it took about 419 milliseconds. The isSmaller call took about 120 milliseconds, and it got ran 1,000,000 times, which if we think about it, iterating over a list of 1,000, checking over every single item of that list for each number, so 1,000 times 1,000 is 1,000,000 calls, compared to get max n, which only checks each element once, it was only 1,000 calls. So from here we can again see the bottleneck again is get max n squared. So let's just say, oh, you know what, get max n squared, let's just replace that with get max n, because they're both doing pretty much the same thing, and get max n is considerably faster. So now if we profile it again, at this stage, it's not going to make a whole lot of difference to profile your code because the runtime is so quick. But we can see here now that we got the same outputs as before, and we should get the same outputs before if we're returning it. So let's try that again, return maxi. So we're getting the same outputs as before, but now our script takes 0 milliseconds to run. So now you can see this is a very simple demonstration for speeding up our runtime. But if we're imagining on a big repository where we have many calls going on, and many of those calls are being called multiple times, this is a great way for you to see where the largest chunk of time is being taken, on what calls, and on what portion of the code, and what we can do to speed it up, if anything at all. So just to review what we did so far, we went through our code, we ran it through the profiler, we looked for bottlenecks, we removed the bottlenecks, checked it again, we saw another bottleneck, we removed it, and ran it again, and optimized our code using the call graph and the statistics provided by the profiler. If you guys found this video helpful, please consider liking and subscribing, and see you guys next time.